We're going to look at transformations of sine and cosine one more time because I want us to see the big picture with all the transformations thrown in there together. We know that this coefficient will affect a stretch or a compression. We know that we call that the amplitude of these functions. That's how we find the amplitude, where our maximums and minimums come from. Remember, the coefficient to x affects the period, whether the function, sine or cosine, cycles through the period of the normal 2 pi quicker or slower. We know that inside the parentheses, if we have plus c or minus c, that is a horizontal shift. We call that a phase shift. And if we just have a real number value, a constant, added or subtracted out here to the whole function, that is going to shift that either vertically up or vertically down. So the same thing is true for the cosine function. All of these players are exactly the same. A is the amplitude, or it gives us a stretching or a compressing of our function. Our maximums and minimums are either lower or higher along the y-axis. B, the coefficient to x, still gives us a change in our period. And plus or minus c is our phase shift to the right or left, and plus or minus k is our vertical shift up or down. So here is a step-by-step process that we need to go through to actually graph these transformations of sine and cosine. The very first step that we want to take is we want to graph the parent function. As you saw on the last couple of lessons, graphing that parent function and taking those interesting points, the zeros and the maxes and the mins, and shifting those up or down or right or left help us a lot when it comes to all of these other changes. The second step that we want to take is we want to identify if there are any changes in the period, and we are going to use that formula that we know, which is 2 pi over the absolute value of b, and remember, b is always the coefficient inside those parentheses to our variable x. The next thing we'll do is identify any phase shift, and that's going to be inside those parentheses, either plus or minus c. Next, we'll identify any vertical shift, and that's going to be after the entire function, and that would be plus or minus k. And lastly, the last thing that we'll pay attention to is that amplitude. We want to see if our maxes or mins are higher or lower than where they are on the parent function. And what we'll do is we'll plot those interesting points, we'll plot all those changes, and then we will just connect them based on what we know the parent function behavior looks like. So the first thing we want to do here is we want to plot the parent function. We know that the parent sine function, we're dealing with sine here, the parent sine function is 0 at the origin. It has a max at pi over 2. It has another 0 at pi. It has a minimum at 3 pi over 2. And it has another 0 at 2 pi, and it's kind of a curvy kind of function that looks something like this. So there would be one period for the parent sine function, y equals the sine of x. So that was step 1 in our process, was to graph the parent function. Step 2 is we're going to identify any period change that happens here on this function, and we can see the coefficient to t. Here, this is the t-axis instead of the x-axis. The coefficient to t is 1, so the period is unchanged. It's 2 pi. Next, step 3, we're going to look for any phase shift. And we can see right here that all of those interesting points that we plotted are going to be shifted pi over 2 to the right. So we might just come in here, and I'm going to take this point, and I know that it's going to be here now. This point will be here. I'm taking each of these interesting points that I have on the parent function, and I am shifting them pi over 2 to the right in the plane. So this function would actually look like so. there's the graph of, this is now y equals the sine of t minus pi over 2. And I guess I should go back and change that to sine of t. The next thing that we're going to handle after the horizontal shift or the phase shift is a vertical shift. And so this one is shifted 3 units up in the plane. So I'm going to take each of those points and I'm going to move them 3 units up. That point goes to 3. This point that was at 1 goes to 4. This point goes to 3. Quit disappearing on me, points. This point now goes to 2, and we'll have this point right here that goes to 3. So now this function is going to look something like, I can draw it correctly, something like this. And this would be the function y equals the sine of t minus pi over 2 plus 3. So the last change that I need to handle is the amplitude change. So instead of going a full 1 unit above where it is here, it's only going to go a third above for that maximum and a third below for that minimum. But these points are going to stay the same. So what we'll do is we'll come here. There is our maximum point. And here is our minimum point. But our what were originally our zeros would stay the same. So now this is going to be the graph of this function. So we can handle all of those changes just one step at a time. Now let's do this one more time for cosine. Let's graph the parent cosine function. We know we have a max at 1, we have a 0 at pi over 2, we have a minimum at pi, we have a 0 at 3 pi, another maximum at 2 pi. So we are looking at the graph of the parent cosine function would look like so. This also is a function in t, so I'll write this as y equals the cosine of t. And then the next thing that we're going to handle according to our step-by-step process after we have graph the parent function is we're going to look for a period change. And again, we can look right here and the coefficient is 1. So there is no period change that we have to handle. And then the next step is a horizontal shift. This is shifted pi over 4 to the left. So we're going to take each of these and let's just put those pi over 4. I'm just going from 0 to pi over 2 and going halfway in between. That would be pi over 4. From pi over 2 to pi, that would be 3 pi over 4. So I can take that point and just pick it up and move it pi over 4 to the left. The distance here, roughly right here, would be 5 pi over 4, and so on. So it's going to take each of these points and it's just going to move them horizontally pi over 4 to the left. So I'm taking each of these points that we have graphed here and I'm moving them pi over 4 to the left. So now this function looks, I'm going to have a minimum there, come back up to a 0 here, and go back up to a maximum there. So now this would actually be the graph of the function y equals cosine of t plus pi over 4. So now we've handled our vertical shift. Let's see the next, I'm sorry, that was our phase shift. The next would be a vertical shift, and I can look out here and there's not plus or minus anything. So this function actually does not have a vertical shift. And the last thing that we need to handle would be this amplitude change. And I'm gonna go with my red function, and all of my outputs are stretched by 4. So what's happening here at 1 is now going to be happening at 4. My zeros are going to stay the same. What's happening here at 3 pi over 4 is now my output's going to be -4. Still going to have a 0 here, and this goes back up here to +4. So now I have a function that looks like this. And we don't change our zeros. Our zeros are still where they are. We know how sine and cosine look in the plane, and all we're going to do is just stretch those outputs. So this is what the graph of this function would actually look like. So there's a step-by-step process to handle all of those transformations, and we can just step-by-step look at all those differences and graph the changes step-by-step, starting with the parent function, and graph one change at a time, and it's much easier to figure out what your final product is going to look like if you'll handle that step-by-step process very slowly, just one step, one change at a time. Come to class next time and we'll work some homework problems.